Okay, ladies and gentlemen, let's take another example of that last style problem. If I have cosine theta equals 0.88, one of the things I can do is I can do two types of problems, sine of pi over 2 minus theta and sine of theta minus pi over 2. Now, unlike the last time where we had secant, which was an even function, both of these sines are odd functions, which means if I have sine of negative theta equals negative sine of theta, the negative that's inside will make its way out just because, like a cube is odd, the negative does not go away. So in this case, I have the property cosine theta. What would it equal to be pi over 2 minus theta? Let's see here. Cosine equals sine of pi over 2 minus theta. Those two are actually equal. So by being equal, whatever this is, and it's done. That's your answer. Now this one, it's turned around backwards. So to get it turned around correctly, we take a -1 out, which allows us to make the theta negative and the pi over 2 positive. But now, because this is an odd function, the negative is going to come out front, -1 sine of pi over 2 minus theta. Well, we already know that cosine and sine of pi over 2 minus theta are exactly the same. So we have the 0.88 goes right here and the -1 out front. So we end up with -0.88. So using cofunctions and odd-even functions, we can combine the two and come up with our answers. Okay, let's head back over to some of our worksheet. In this case, we want to simplify this expression. Now, simplify means make it more simple. Well, this does not look like any property that I'm aware of over here. This is not one of our standards. So what I'm going to do is I'm going to say, I don't know all my cosecant and cotangent properties. So let's change them all into sines and cosines. So here we go. Cosecant by reciprocal property is 1 over sine x. Minus cosine x, I'll keep it because I'm used to those. I like those. Cotangent by quotient property is going to be cosine x over sine x, or theta, I guess. I need to stay consistent. X. There we go. Now, in this case, we multiply together. We come up with 1 minus cosine squared x all over sine x. Now, the nice thing is you say, wait a minute, that I do recognize. That should be one of my properties. And in fact, if I come over here, we added two Pythagorean properties that are always true, and that's sine squared x equals 1 minus cosine squared x, and cosine squared x equals 1 minus sine squared x. So in this case, we're going to say 1 minus cosine squared x is sine squared x. This is why you have to know the properties inside, outside, upside down, because you need to be able to recognize them when they're in a problem. So now I have sine squared over regular sine, one cross off top, one cross off the bottom. My answer is sine x. Now, we're going to do basically the same thing down here. We say, well, wait a minute, what can I do up here? Well, secant, I could do one of a couple things. One easy way would be to say tan x plus sine x times 1 over cosine x, because secant equals 1 over cosine x, all over cosecant x tan x. Now, what is sine x times 1 over cosine x? Well, that's sine x over cosine x, which equals tan x by the quotient property. So by putting this together, we actually have tan x plus tan x all over cosecant x. So that gives me 1 tan x plus another tan x is 2 tan x all over, sorry, I forgot to write the tan x here, cosecant x tan x. Cancel. I'm left with 2 over cosecant x, or 2 sine x. There we go. Now, that's kind of a lot, but again, we're just using the properties over and over and over again. Let's do a different style of property. let's do a different style of solving. So that would be one way to solve. And there's your answer. In this case, I could just go all sine cosine. Sine x over cosine x plus sine x. That's going to be 1 over cosine x all over 1 over sine x times sine x over cosine x. And if that's the case, we're going to say 2 sine x over cosine x, cancel, cancel, over 1 over cosine x. And to get rid of the double fraction, I'm going to multiply top by cosine x and bottom by cosine x. Cancel, 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 and I'm left with 2 sine x. So an entirely different way to do that problem. Now, let's take a look and go a little bit further here. Let's come down and take a look at number 32. Number 32 says simplify each expression. Now, in this case, I have two fractions. Well, if I have 1/3 plus 1/2, the way I would get those together is I would multiply to get a common denominator. In this case, 2 and 2. This case, 3 and 3. I'd have 2/6 plus 3/6, which is 5/6. Okay, sounds good. Let's do the same thing here. I have two fractions. The bottoms are different. So I'm going to multiply this by something and this by something. In this case, since they're not the same, we're going to take this denominator, just like we did, and multiply it top and bottom. Secant x plus 1, secant x plus 1. Here you get secant x minus 1 from this side, secant x minus 1. In which case I have secant x minus 1 times cosine x plus cosine x times secant x plus 1 all over. Now, since this is a 2-part by a 2-part, I'm going to have to FOIL it out. Secant x minus 1, secant x plus 1, gone, gone, gone. This to this, secant squared x minus secant x plus secant x minus 1. Now the two middle terms go away, and I'm left with secant squared x minus 1. Now I say, wait a minute, secant squared x minus 1. If I subtract 1 from both sides, I have tan squared x equals secant squared x minus 1. So secant squared x minus 1 equals tangent squared. So I have a tan squared x on the bottom. On top, I have to give it away. Secant x cosine x minus cosine x plus secant x cosine x plus cosine x. Well, what is secant times cosine? Well, since secant is 1 over cosine, those two are going to cancel out. Those two are going to cancel out, leaving 1 and 1. And I end up with a negative cosine and a positive cosine go away. So 1 plus 1 is 2 over tan squared x. And that's about as simple as I could get. If you wanted to, you could go cotangents, 2 cotangent squared x. All right. Now, that's one of the things that it allows us to do. Let's go ahead and finish the last problem. In this case, it says get rid of the fraction. So to get rid of the fraction, I'm going to need to multiply top and bottom by something. If I have 2 over 1 minus root 3, to get rid of the 1 minus root 3, I would multiply by the conjugate, 1 plus root 3, 1 plus root 3. FOIL it out. So here, if I have 1 minus sine x, let's multiply by 1 plus sine x, 1 plus sine x. If I FOIL this out, 1 minus sine x, 1 plus sine x, 1 and 1 is 1, minus sine x plus sine x minus sine squared x. So the two middle terms cancel out, leaving 1 minus sine squared x. And on top I have cosecant x times 1 plus sine x. Give it away, give it away. And that allows me to say cosecant x plus cosecant x sine x all over, wait a minute, 1 minus sine squared. 1 minus sine squared is, where do we go? 1 minus sine squared, cosine squared x. So that gives me cosine squared x. Now, cosecant and sine cancel out. And the best I can come up with is now I have cosecant x plus 1 all over cosine squared x. Now, that does not get rid of my fraction, but that's okay. I now have it to where I can say, wait a minute, 1 over cosine equals secant x. So I can take this and move it up top, and so now my final answer is cosecant x plus 1 times secant squared x. And now I have no fractions left. So we went from here to here, on down to here, and back over using our properties. Now, folks, I did go through it fairly fast, but once you get a little practice at it, remember here is problem 39, so it's getting pretty tough by the time we start talking about problem number 39. So from there, take a look and see what you can do.